All right, welcome to class. We're gonna look at lesson 4-6. Talk about inverse trig functions. Raise your hand if you haven't. Oh, sorry, you can't raise your hand. There are no questions. Okay, so I'm just gonna run through these really quickly as if this was a real lesson. You just pay attention to what's here on the screen, and every now and then you can pause and go to wherever you want to. Somebody's coming. Oh yeah, here we go again. I was interrupted there. So here's our objectives. You're going to want out your book. You're going to want to have your notes. You're going to have your pen. And go ahead and list those objectives in your study guide book. Feel free to pause me at any time so you can write those things down, and then unpause me when you're ready to go again. So there they are. There's our two objectives. Hopefully you got those down in your notebook, and look down through the vocabulary as well. Arcsine, arccosine, and arctangent are just inverse functions. So if you put sine to the -1, it's the same thing as arcsine. Same with the other ones. Here's page 2. The inverse of some functions, including trig functions, are not functions. So what good are they? The job of inverse trig functions is giving a value or a trig ratio such as the sine of an angle equals square root of 3/2. Your job is to retrieve the angle measurement, or theta, that corresponds to that particular trig ratio. And there is a one-to-one correspondence with those. In the example above, the theta is 60 degrees or pi over 3 radians, because that's where sine equals square root of 3/2. Graphically, inverse trig functions have to have restricted domains so that they don't retrieve more than one angle measurement for a given trig ratio. If you leave your inverse trig function like the parametric inverses that we used the other day, it wiggle wobbles vertically, and you could cut a line through it and find more than one place. If you plug in an x, you find more than one answer for the y. So we restrict our domains so that we only have one answer that corresponds between the function and its inverse. Sine functions restricted to the domain of -pi/2 to pi/2, and you could write that in brackets because it can include those. The inverse sine function then has a domain from -1 to 1 and a restricted range of -pi/2 to pi/2, what we restricted the original sine function's domain to be. Remember that with inverses, domain and range just switch places. One becomes the other for the inverse. Please note, if we are using the unit circle to find our angles, we are looking in the first and the fourth quadrants, or kind of more technically the first and the negative first quadrant, because we treat those ones in the fourth quadrant here like they're negative angles. So I'll show you what those look like here. The blue is our normal sine function. I've cut it off here at these lines to restrict that domain, and then I've taken the inverse of it, and that's this here in red. You can see that they're inverses. You see those endpoints there are just reflections of each other on both sides. Here and here are inverses of each other. So if I plugged in a ratio value like 1/2, I would find the angle measurement somewhere on that red line that corresponded to that. If we're looking at the unit circle, we're looking at quadrant 1 or quadrant 4 for our values. Cosine is very similar to that, except that cosine is restricted to 0 to pi, or quadrants 1 and 2. The reason for that's the same as it was for cosine. It's so that the inverse doesn't loop back on itself and create a problem for us for finding inverses. So here we have our normal cosine in green. We have our inverse, restricted, range. Flip-flop it. You see the endpoints there of the red line correspond to the inverses of the endpoints for the green one. You can see here that this point right here is at pi -1. Its inverse is -1 and pi. Your angle answer is on there somewhere in radians, between 0 and up here at pi. If we're talking about the unit circle, this is where we get to look at quadrants 1 and 2. So sine and cosine are very similar. They just have a 90-degree difference or a pi over 2 difference in the domain, the restricted domains. One is a little bit ahead of the other one. And then there's inverse tangent. Tangent goes up and down rather than oscillating like sine and cosine does. Inverse tangent, at least on the restricted domain, looks a lot like part of a sine function. We restrict the domain for tangent functions between negative pi over 2 and pi over 2. But notice that we're using parentheses rather than brackets because it can't include those. If we're at the very top of the unit circle and trying to find a value for tangent up there, we can't find one because the value for it's undefined. So we can go up to it, but not quite touching it. Same thing at the bottom of the circle, negative pi over 2. That's undefined down there as well. So we use the parentheses instead of the brackets. Here's what inverse looks like on a graph. It's here in red. Regular tangent was the one there in blue, and you can see here that from the line y equals x, that the red one is a reflection of the blue one. And so the values for inverse tangent are going to be somewhere on that red line. Last slide here, if we're looking at tangent and we're trying to discover where our angles are going to be, we're allowed to look in the first and the fourth quadrants. The first positive section and the first negative section from where we start. So there you go. That's our test lesson. Um, you can check this anytime. You can pause it anytime. Go back and watch parts of it over again. If you didn't get something, then pause it, look at the screen, write stuff down, use your book, compare all that stuff. And if you have questions, you can bring those to class.